Our product is unlike conventional robots. It's not actually a robot, it's a robot system. So that means it's a set of modules, standard robot components that can be configured to create many different types of robot. The original idea for the robot system started with modular toys for my children. I was looking at their construction toys and wondering why so many parts were needed to create one construction, like a pirate's castle or something like that. And I started looking at three-dimensional modularity rather than two-dimensional modularity, and developed a modular system based around one part that can be reconfigured with identical cousins to produce an infinite number of different assemblies. The system is plug and play, so you can put different types of sensor and tool on the robots and they will work instantly. And so that might be a camera like this, which plugs onto this robot. It might be a LiDAR scanner, it might be a sensor for gases or explosives or radiation. Tools can be robot arms, drills, cutters, paint sprayers, sanders, whatever you like. And another category of accessory that as we think of it, is artificial intelligence, which can also be plugged into the robot platform and made to work immediately. We've been working with Maxon for 7 or 8 years now, and this dates back to the early part of our development process. Why we've been working with Maxon is that we were looking for a very compact motor that would fit into our modules. The space, the volume was very restrictive, and also a motor that would be very reliable and have a lot of torque, because what's critical in a little lightweight man-portable robot is torque, not power. Our initial focus is on the nuclear industry, and that's because the type of user there understands robotics, has used robots, and understands the virtue of having a modular and reconfigurable system from which you can develop many different applications using standardized parts. Thereafter, we see the biggest opportunities in oil and gas, which is an adjacent industry with many very similar problems, and therefore the technology will transfer quite effectively, we think. And then very close to oil and gas is utilities, so the distribution of water and gas, and mapping and maintaining those assets using robots. So one of the biggest challenges we found was reliable mobility in difficult to access places. And if you think of the kinds of terrain that the robots are deployed in, it might be sand, mud, ice, snow, oily places, down sewers, up metal steps in the rain. The answer turned out to be cockroaches. And cockroaches' little legs, like these legs which we call claws on our traction system which we've developed, are very good at getting around places that wheels and tracks are very poor at doing. The problem we had before using Maxon products was that we couldn't find a motor that would actually work inside our modules in terms of the form factor and the performance. We had to get a very small compact motor into our modules that would give the performance of a much bigger motor. There are other motors, but they don't have the same energy density, and they're not as reliable. There were lots of factors in favour of the Maxon motors. We're looking to stay with Maxon for the foreseeable future, largely because we don't want to change the specification of our system once we've frozen it for our end user. If something works, don't fix it.